Hello everyone and welcome back to my channel. Today we are going to see how to build this kind of surface here, that are surface that start from a flat surface and became a thin surface in the middle. We can move these elements using a slider, and so it is perfectly parametrical. And once you have this definition, you can apply to different field, from the architecture to the mechanical one. To obtain this kind of surface, we start from a new document in Grasshopper. Then I will create a rectangle. I'm going to import it inside Grasshopper. So I create a curve container, set one curve, I select my rectangle. Then I'm going to explode it in order to retrieve the edges. So I want the opposite edges, so I'm going to take list item, and using parameter I'm going to choose two opposite edges of the same rectangle. So the first edges is at stored at the index 2, and the right edge is stored at the 4. Perfect. Now I'm going to evaluate a point inside this curve. So evaluate curve, and I'm going to reparameterize the curve, and I'm going to create a 0.5 slider so I can move perfectly inside my curve. Now I'm going to create another point inside the second edge, just like we have done before. Now I want to create two segments of line inside the rectangle. So I start from the point on the left, and then move it in direction we can see in shaded view, in direction epsilon less, so negative epsilon. So epsilon, it has to be negative, and I want to define the intensity of this movement. It can be, for example, 4, like a parameter. So I give 4 to epsilon to neg, and then I link epsilon to move. Okay. And now I will move of the same amount on the left, the point that is now in the right. So I copy all these elements. I want the two segments of line to have the same length, so I will connect the same parameter to define the length. So now I can draw a line from the first point to the moved point, and also in the second part from this first point to the second point. Perfect. Here we don't need of the negative because I want to move the point inside the rectangle. Perfect. Now I want to create another little line in the center, so I'm going to evaluate the center of this rectangle. To do this, I can find for example, the length of the epsilon length of the rectangle, and to do this we can select the item that represent this line, and the element is the number 3 into the explode output S. And now we are going to take the central point. You know that if you reparameterize a curve, the central point is at 0.5. Okay, this is the central point. Now I have to move it from here to here, meaning from the bottom to the top. So and to control it by a slider. So what I can do is move this to create the vertical line here, and to create the vertical line I can evaluate this distance. So I do a line from here to now better. I'm going to evaluate the length of this line. So length, now I want to move the line on the left, the vertical line on the left, of half of this length. So I'm going to divide the length by 2, and now I'm going to move all this curve, move in direction epsilon negative. I can copy from here, of this amount. So I have a vertical line on the center. Now I'm going to evaluate a point inside this curve. Evaluate curve, and I'm going to use a slider 0.5 to define the reparameterize the curve to define the position of the point inside of the curve. Perfect. Now I'm going to move this point on the left and on the right of half the factor that define the length of this little segment, because I want 3 segments of the same length. So I want to move it in the right side, so epsilon of half of this length. So I give a panel to it by 2. So I'm going to connect it, and so this is the first moved point. I want to create another moved point. This time will be moved in the negative direction, and this is the second point that we obtained. So now I'm going to link with a line these 2 points. Perfect. These are the starting line that we use to define our geometry. Now I'm going to design the curve, so we are going to blend this segment together. I will blend this first with the central one and the central one with the last. So we go on curve, spline, blend curves, and so I'm going to blend this segment with the second segment, and what I want here is not 1, is 0.5 here in FA and FB. So I create a panel that for me is a constant, so I use 0.5 and I obtain this kind of curve. I will do the same with the following couple of curves. Look, now we have to make some changing here, because if I move the blending, the initial blending is in this way, but we are not, it is not okay for us. What we want is to flip the central curve before using the blend curve. So we use flip in Grasshopper, flip curve. I'm going to flip this curve before entering into the blending. Okay, now the curve is okay. So now we are going to build the main curve. Before doing the main curve, we have also to move this central curve in order to give also a zeta characterization of the curve. So here we are going to enter with a bypass here. We have to move this this line vertically. So so we can create two bypass here, and I'm going to move this vertically. So move in direction Z of an amount of defined by a parameter. So I use like 10, and now I'm going to connect the G output to the bypass to the relay elements I just created. Okay, so now the curve have also a vertical characterization. Now I can join all the curves. So we have the first curve that is stored here, the second curve that is the blend curve that is stored here, then we have the third curve here, the fourth curve here, and the last curve here. We can join them, we can flatten them, and here we have the main curve. Perfect. Now what we need is to project this curve on the plane. So we use project an object onto a plane. So this will be our object, and the plane by default is XY, so it's okay for us. And this is the curve. And now we are going to offset this curve. The distance is very important parameter here, because it will define how sharp will be my final curve, my final surface. So we create an offset in the positive direction and an offset in the negative direction. So Okay, we have to offset here, and this is my main core. So now what we have to do is to create some curves that will define our sharp surface. So first of all, we create we take the main curve and we create perpendicular frames. Is division perpendicular frames starting from the main curves, and we are going to eliminate the last one and the first one, because I saw before that they will create problem with some configuration, some particular configuration of the curve. So we are going to cut them. To cut them, we are going to use a list option, so list, split list. We are going to cut the first one that is always stored at the index 0, so I use one index to separate one list from the other. So we have 11 values. Now we have to take the list with 10 values, and we are going to split another time this list of what? Of the length of the list less 1. So we use list length, and we are going to subtract 1 from this list. We should have a list of 9 elements that in particular are plain. Okay, we have these 9 planes here. So what we are going to do is with this plane we are going to intersect the offset curve here, and to do this we are going to create intersection between a plane and a curve and plane, this here. Okay, now we take the curve we want to intersect and the planes. Okay, this is the intersection with the first offset curve. Now we are going to play the second intersection here. Okay, perfect. We are going to disable a preview of this plane that are going to disturb me. Okay. Now we have to also to do the intersection between plane and the main curve. And here we are. We have a set of point. Sorry. Yes. We have a set with the same length because it's always 9. Because we divided the first curve by 10, it was stored here in n count of perpendicular frames. So now what I want to do is to create a particular link from the offset curve to the main curve. So we will use the command barc. So we are going to create this Bezier span. Yes. What is asking us this command? What it takes by input? It takes the starting point that, for example, could be this one, the start tangent, and the end of the ending point, and the ending tangent. So what we want is basically that at the beginning, so in these points, the tangent have to be x, because the the other part of the surface are flattened, so the tangent to the surface will be x, the x vector, and the top it will be z. Then we will see that we'll start some problems that we will try to avoid with another little part of definition. So first of all, I want to connect this point with this point. At this point, what should be the tangent vector? It will be z, because here I want to have a kinky curve, kinky edge. So here I will insert the vector z, and here I will insert the vector x. Let's see how it works. How can you see here is not working as I wanted, because I want the curve to arrive in the opposite direction here. So easily I will change the value of from z value to less z, and here we are. These are the curve I was looking for. Now I will do the same with the other offset curve. So for the moment I copy everything, and I only change the starting point here, and we can see that it's working almost good, but here is not working well. Here we have to change the value from x to less x to minus x. Okay, this is seems to work, but and we can also start to see how is the final result. So we can, for example, join this curve, join curves. So we are going to create 9 curves, and this will be the curve in the u direction, and now we have to find the curve in the v direction. So we can take for example, let's try if it works with directly with the 2 offset curves here, using them as a curve in the v direction. So we are going to create a network surface, and we use this curve as the u direction and this curve as the v direction. We are going to flatten all. Okay, this surface is almost good, but it's not properly the result I wanted, because you can see here it's not working as I wanted, because here I would like that less the point is height, more the tangent of the intersection point became like the x vector. So I can write a little part of code before inserting here the values of the vectors. So this is already a good result. If we see it, the result is not so bad, but still have some problems. For example, if I create a flat surface here, the result is not perfect, you can see. So what we can do here is to say, okay, at the meeting point here, the tangent is not constant, but is variable depending of the on the height of the curve. Where is defined the height of the points of the curve? We know that we here are stored all the points, so to have the height is very easily. We can deconstruct the point, deconstruct vector. We can take the z component, and we can say, okay, let's compare this component, let's bring all this value inside a range that we can easily manage. So we can reparameterize numbers, and so we are going to reparameterize the z value from 0 to 1. These are the values. Okay, and what we want that when the value is 1, the result should be the z vector. When the value is 0, the result has to be the x value. So to do this, we can start from an x vector, and we can rotate vector, there should be a vector command here, rotate a vector around an axis. So we can rotate the x vector around the axis y. Of which angle? The angle will come from have to depend on this value. So for example, we can multiply these values from the 90 degree. So when the value of the height will be 1, the angle will be 90, and so the x vector becomes the z vector. When the angle is 0, the x vector remains x vector, and it takes angle in radians, so we are going to change the values from degree to radians. Okay, so now I have 9 values of my vector that I'm going to connect here and here. Now okay, now I have to duplicate. Let's see what angle we have here. 90, 90, 90, 90, 14. Okay. Now we have also to duplicate these values because otherwise the lists are not coherent. So I'm going to duplicate these values until they are 9. So until they are, for example, the list until the list is long like this. So I'm going to evaluate list length. This is 9. So I'm going to create 9 duplicates of the x value, and so here I have a list of 9 x values. I'm going to give to b, and I'm going to create duplicates also here. Perfect. Now I have to play a bit with the segno, with the minus and plus, and no, maybe I did a mistake, because the first point were the one on the offset curve, so I have to invert the vectors. So the vector that I found it with this definition have to be connected to the b, sorry, and the vector obtaining duplicating the value have to be connected with the a. Okay, so now it sounds me to be better. The only thing here is that I duplicated I have to duplicate the x vector and not the z vector. X vector here and also x vector here. Okay, it is very much better. And you can see we still have this problem here. Is a little problem, but I think we can solve it increasing the division point of the first core. So we are going to increase the perpendicular frames here, not to 10 anymore, but we are going to use 15. Okay. Now it's going to work, because the division point is entered into the first division point is entered into the segment of line that was flat. So now it is working perfectly. Now to obtain the result of the covering of my video, you can create a surface, a flat surface here, curve, boundaries, okay, set one curve, okay, and now we are going to copy all these elements here, not the surface I just created, all these elements, Ctrl C, Ctrl V, and now we are going to move this parameter as we want. copy this another time, for example, and I'm going to move the starting curves exactly as I want. So the central part is driven by this thing. Yes, perfect. And for example, we can also move the 8. The 8 was driven by the move here. Okay, and then we can give material preview also to the boundary surface here. I'm going to add with using shift to the preview, and now I'm going to disable preview. Okay, and I can play with my elements in order to have the better result I want. Okay, I hope you enjoyed the video. Please like and subscribe to my channel, and have a nice good work.